Hello scholars. Today we're going to talk about rational function and all the different features of the rational function. So at the end you are going to learn how to find the vertical asymptote, holes, and x-intercept of the rational function without looking at the graph. So you're going to be given the function like this, and you should be able to tell me how to find all of that. So before that, let's just investigate a few things. Okay, so look at this rational function, two of them. Both of them has, let's see, so this one has a vertical asymptote right here at x is equal to 1. So I'm going to write it down. Vertical asymptote at x is equal to 1. What about this one? Vertical asymptote at x equal 1 as well. Are you with me? What about the hole? Well, there's a hole. I know you can't really see it. There's a hole right here. So hole at what? -1 comma 3.5. I want to say. All right, what about this one? There's a hole here. -3 comma 0.5, I want to say. Last but not least, what else do we have to know? X-intercept. Where is the x-intercept? Where it crosses with the x-axis over here. So x-intercept at 2.5. X is equal to 2.5. And this one, x-intercept at x equal -1. By the way, x-intercept has lots of different names. X-intercept is same as what? Roots. Same as, I'm blinking, what is it? Zeros. Cool. Alright, let's go. So, look at this huge table. So, we're gonna go fill it out. Follow the direction and then come up with the characteristic of each one. Ready? So develop the graph of rational function, understand between equation of the function and graph. Let's go. Alright, so there, by the way, these are the same as the function in the front page that we did. Okay, it says number 1, rewrite function in completely factor form and identify restricted values. So let's go ahead and factor. Alright. Let's do the numerator first. I'll probably do A, C, B chart, right? So A times C is -10, B is -3, two numbers, -5 and 2. I'm just going to do it here. Okay, so 2x squared minus 5x plus 2x minus 5x, 2x minus 5 plus 1, 2x minus 5. So your numerator is going to be 2x minus 5 times x plus 1. What about denominator? That's a difference of two factors. Squares. So it's x squared minus 1 squared. It's all algebra 1. X plus 1. X minus 1. So I'm done factoring. Now what? It says to find the restricted value. How do you find that? Restricted values are the one that makes your numerator equal to 0. The ones that makes your denominator equal to 0. So restricted value, how do you find it? Set your denominator equal to 0. So I have x plus 1 equal to 0. X minus 1 equal to 0, x is equal to -1, and x is equal to 1. Cool? Alright, it says identify domain from the graph. Okay, are you ready? There's a graph. What is my domain? Domains are the x values. So it's going to go up -infinity to, boop, oh, there's an open circle, so I got to stop. -1, and starts again at -1 till, whoop, 1. I gotta stop at 1 because there's a vertical asymptote. And 1 to positive infinity. So -infinity to -1, union, -1 to 1, union, 1 to positive infinity. Some of you already start seeing the pattern there. Alright, let's keep going. Now it says set non-canceling factor of the numerator equal to 0 and solve. So if you look at the factor form here, you kind of see that x plus 1 kind of cancels, right? So it says non-canceling factor of the numerator, which is 2x minus 5 equal to 0. And solve it. I get x is equal to 5/2, which is 2.5. What is the 0 of the function according to the graph? Where was your 0? X-intercept was at where? 1.5. 2.5. 2.5. 2.5. You see the pattern there? Okay. what is the value of the constant term of the numerator over constant term of the denominator? So you go back to the original. Constant term is a number without the letters, right? These are all have the x in it. The constant term of the numerator is -5. Constant term of the denominator is -1. So just constant, constant. So what's that? 5. Now it says, what is the y-intercept? Where's the y-intercept? Where it crosses with the y-axis? 5. Y is equal to 5. Okay, so if you are a smart person, which you all are, you kind of see that two answers are the same, right? So that one, these two. So that one was from the equation, that one's from the graph. That one was from the function, that one was from the graph, that one's from the function, that one's from the graph. Same answer. So if you've been taking my classes a long time, you know that we are talking about pattern here. Okay, let's do one more. Let's do one more. The second one, how do you factor it? It's going to be, use the same color. Factor form is going to be x plus 3, x plus 1 over x plus 3, x minus 1. And identify restricted value. Set my denominator equal to 0. X plus 3 equal to 0. X plus minus 1 is equal to 0. I get -3 and 1. -3 and 1. Now it says look at the graph, identify the domain. So we're looking at the second graph. So what will be the domain? -infinity till, open circle, stop at -3. -3 till, boop, stop at 1, the vertical asymptote, and 1 to positive infinity. -infinity to -3, union, -3 to 1, union, 1 to positive infinity. It's not climactic, isn't it? Alright, next. Non-canceling factor of the numerator equal to 0. So my numerator over here, the factor form, x plus 3 is canceling factor. So non-canceling factor of the numerator is going to be x plus 1. X is equal to -1. What is the 0 of the graph? Where's your 0? Where's your x-intercept? Right here at x equal to -1. X is equal to -1. Aha! Alright, next. Constant term of the numerator over constant term of the denominator. So I go back to the equation over here, function here. Constant term of the top is 3. Constant term of the bottom is -3. 3 over -3, -1. Y-intercept. -1. So now, are you ready? We're going to write down how to find each one without looking at the graph. So, number 1, how would you find the restricted value? By the way, restrict value on the delta mat is going to use the vocabulary called undefined. So how would you find the undefined value? Set your denominator equal to 0 and solve. Right? Isn't that what we did? Set your denominator equal to 0 and solve. What about the domain? Domain will be every x value except these ones. What are those ones? Restricted values. Alright, your domain. How did you find the domain? It was everything but those two restricted values. It was everything but those two restricted values. That's how you find the domain. How do you find the 0? How did you find these two without looking at the graph? You're going to set non-canceling factor of the numerator equal to 0 and solve. Non-canceling factor of the numerator equal to 0 and solve. That's how you find the zeros. What about the y-intercept? It was what? How did you find this 5? Constant over constant. Constant over constant. Okay, are you ready to practice? Let's go. Let's practice. Right here. So I already factored this for you. This is a practice problem. That's a factor form. That's a factor form. Now it says to find the restricted value and domain. How do you find the restricted value? Set your denominator equal to 0. So 3 and negative 1 are the restricted values. So restricted values are these. What will be the domain? What do we put in a table? Domains are everything except those values. So everything except 3 and negative 1. So it'll be negative infinity to negative 1, union negative 1 to 3, union 3 to positive infinity. Notice that I put the negative 1 first because that's a smaller number than 3. Good? Alright, what about the 0? Go back to the table. How do you find the 0? Zeros. Non-canceling factor of the numerator equal to 0. So when I look at it, well, we can kind of cancel the x minus 3. Non-canceling factor of the numerator is what? 3x plus 1, 2. X is equal to negative 2 thirds. 0, 0. Y-intercept. Constant over constant. So you can't really look at the factor form. You need to look at the original one. So constant is negative 3, negative 6, constant is negative 3. So negative 6 over negative 3 is equal to 2. And let's be nice. Over here it's going to be y is equal to 2. Does that make sense? Be quiet, sir. Okay. Alright, let's do one more over here. Restrict values, denominator equal to 0. And watch, when I said denominator equal to 0, notice that I am including the one that's canceling, right? Negative x minus 2 has to be included over here. You just don't do it over here when you find the zeros. So domain will be negative infinity, negative 2. X-intercept, non-canceling factor of the numerator, which is x plus 5. Y-intercept, constant over constant. Negative 10 over negative 4, 5 half. So y is equal to 5 half. Okay? Alright, let's do one more practice. Over here. Does it fit? There you go. So we're going to do the same thing. Rewrite the factor form and identify restrict value. These two are the copy of the previous page. So I'm actually going to pause it and write it down and start. Alright, so I wrote it down in a factor form. I found the restrict value, and next it says write it in simplified form. That simply means that cancel out what you can and write it down. So I cancel that out, boop, cancel that out, boop. Does it make sense? Alright, next. What factor cancels out of the function and what type of discontinuity happened at the restricted value? Okay, so which factor did I cancel? X plus 1 equal to 0. X is equal to negative 1. So this is asking you what happens at x equal negative 1. What happens at x equal negative 1? What is that? A hole. There's a hole. Alright, it says find the value of the simply form of the function when x is this value. So this is saying that now plug that negative 1 into the simplified form. Okay, so 2 times negative 1 minus 5 over negative 1 minus 1 equal to negative 7 over negative 2. 7 half, 3.5. Now it's saying, what are the coordinates of the holes of the graph? What was the coordinate of this hole? Negative 1 comma 3.5. So, in other words, how would you find the y value of the hole on the function? You take that x value and plug into the simplified form, and it's going to give you the y value of the hole. What factor does not cancel out of the denominator? Okay, so on your denominator, which one did not cancel? X minus 1. So what happened at x equal 1? What happened at x equal 1? The dotted line that your graph gets closer to but never touches it. Vertical asymptote. Cool. Alright, let's do one more. Ready? The next one over here. What cancels out? X plus 3. X is equal to negative 3. So looking at the second graph, what happened at x equal negative 3? A hole. Now it's saying that take that negative 3, plug it into the simplified form. what was the coordinate of the whole? -3, 0.5. So that's how you find the y value of the whole. Now, non-canceling factor of the denominator. Which one did you not cancel? X minus 1. X is equal to 1. What happened at x equal to 1? Vertical asymptote. Alright, now let's find out how to find each one. How do you find the x value of the whole? Like, how did you find this? It was the canceling factor equal to 0. Alright, how do you find the y value of the whole? Plug this x value into simplified form. Alright, we plug that -1 into the simplified form to find the y value. We plug that -3 into the simplified form to find the y value. How do you find the vertical asymptote? Non-canceling factor of the denominator equal to 0. Alright, practice. Let's go. Let's just do the one on the left. We don't have time. Simplify form. 3x plus 2 over x plus 1. How do you find the x value of the whole? Look at the table on the previous page. X value is the canceling factor equal to 0. Canceling factor. X minus 3 equal to 0. X is equal to 3. How do you find the y value? Take that 3, plug it into the simplified form. Wow, I can't do math. 7.5. You can leave it as 11 over 4. Vertical asymptote, how do you do it? Non-canceling factor of the denominator. X plus 1 equal to 0. X is equal to -1. Perfect. We did it all. So today's lesson, we learned how to find what? Restricted value, which is same as undefined, domain, x-intercept, y-intercept, wholes, and vertical asymptote. Thank you. Bye-bye.